we're supposed to evaluate this function at 125 even though we don't have an explicit form for f. All we know is what f does to certain combinations of inputs. And most of us are used to an explicit form like f of x equals square root of x, f of x equals the log of x or something. But here we don't have that. Again, we just have what f does to a variety of inputs, and we know that it's equal to this constant on the right-hand side, 2008. Now, the power that we have going for us here is it holds, this expression holds for all real x. This is the universal quantifier for all. Now, just a kind of a warm-up on this, if x were 0, we could quickly write down 2 times f at 0. Okay, the 2 comes from the fact I put a 0 right here and I put a 0 right here. Now when you put zeros here and here, you will have minus f at 5 equals to 208. And again, we just exploited the fact that it holds for all x, and of course 0 is a real value of x. And so again, we put a 0 here, a 0 here, a 0 here, a 0 here, and if I didn't make any mistakes, this is what you get. Now, does that help us get f at 125? I don't think so. But that's just an idea how you typically work with it. Substituting 1 and 0 are typically approaches on problems like this. Now let's go a step further and see what we can do towards finding f at 125. And again, this has not much to do with this. It's just showing you how you might proceed, using easy constants. Okay, now, again, I stress our functional expression here holds for all real x. And so what we're going to do is take the only thing that's concrete here, x cubed and 7x squared minus 11x plus 5, and turn that into an equation and see if we can solve it, because any solution to that equation would have to be tested in this expression up here that we're trying to solve. Okay, so what I did is equated x cubed, which is the input to f right here, with 7x squared minus 11x plus 5, which is the input to the f right here. So you see, I just simply equated that. Okay, now I won't spend too much time on this. This ends up being equivalent to a cubic, and the solution, the only solution, I believe, there may be complex solutions here, but x equals 5 is a solution. Okay? But what does that tell us? That tells us that this side equals this side. Okay, so we know that this side is equal to 125. That's very simple. But that also tells us this piece right here has to be 125 also. We don't have to directly evaluate this. We just know it has to be 125. Okay, all the work was done in determining that 5 was a root here. It's not particularly difficult to, you remember that all the divisors of the constant term are potential rational zeros. 5 is a divisor along with minus 5 plus 1 and minus 1. 5 turns out to work. So you could verify that right here. And so now we know that 125 equals 125 in these two different forms, right? So what does that do for us right here, folks? Well, if we take x equals 5, okay, put it right here, this gives us minus 3 times f at 125. Okay, and then we already know, as argued up here, this is also f at 125. So you have minus another copy of f evaluated at 125. Okay. And y'all, literally, I think this is about the only thing you can do on a problem like this. I don't know of any other constants you could try. You have to use the concrete functions in some fashion to see if you can make any leeway. Now, notice, so we have minus 3 f at 125. So what is this? Minus, if you collect like terms, you have minus 4 times f at 125. Equals 208. Okay, And then to figure out what f at 125 is, of course, you're going to divide by 4, and I chose the constant to work out nicely here. So f at 125 is equal to whatever you get when you divide this by minus 4. That is minus 52, it appears. Okay. So that's the solution. Again, dividing 4 into that gives you minus 152, and so that's f at 125. So we finished the problem. Now, I don't know if there's any other way to find this unless you work directly with these two concrete instances of functions. I don't even know if you can find f at 0, or it's this. I don't know of any other constants you can find other than working. Now, this may have complex solutions which you could work with also. I'm not sure. Probably not, because it wouldn't work out very nicely if you had complex numbers in here. When you would have imaginary parts and stuff floating around. I doubt it would work out nicely. But in any event, this is the answer. F at 125 is minus 52.